So imagine you are stepping off a gangway and onto this massive, complex floating city for the very first time.
Oh man, it is completely overwhelming.
Right. You're an officer, you've just been assigned to a new vessel, and you're staring down these corridors of just endless steel decks. It's an absolute labyrinth.
And you have to remember, lives are on the line. Millions of dollars in cargo are beneath your feet.
Exactly. And you're immediately faced with the reality that you do not know where anything is.
It's a really disorienting scenario, but I mean, it happens every day in the maritime industry.
Yeah. Which brings us to today's mission. We are going on a deep dive to explore the hidden DNA of maritime survival and operations.
It's a fascinating topic. We're unpacking a really intriguing document today.
We really are. It covers Chapter 14 of a highly regarded maritime text focused entirely on ship construction plans.
Right, and this material draws heavily on some foundational naval architecture texts.
Specifically, we're looking at the work of Dr. Spyros Hridaris and DJ Ayers.
Yeah, these are essentially the definitive texts for understanding how these massive leviathans stay afloat.
Because the ship isn't just, built and pushed into the water.
No, not at all. It is comprehensively mapped and mathematically modeled.
Right. And to ground us, our source material actually provided this incredible split image that just perfectly captures the duality we're talking about today.
I love that image. It really sets the scene.
It does. So on one side, you have these highly detailed, almost sterile schematic views of a ship.
Very technical.
Extremely. There's a side profile, an upper deck layout, and this dizzying grid literally labeled tanks and double bottoms. It looks like an X-ray of the ship.
And then on the other side of the image, you see the messy physical reality.
Yeah, these oversized, sprawling blueprints just laid out across a desk.
Right, cornered by a red pen and just waiting for someone to make a quick calculation.
And one of those blueprints is clearly titled General Arrangement. It takes all that abstract math and makes it feel, immediate and urgent.
Which perfectly illustrates the foundational truth of our source text today.
Which is?
The text explicitly states that it is simply not possible to know every ship in detail.
Wow, so human memory just isn't enough.
It really isn't. Officers and engineers are entirely reliant on these plans provided by the builder and the owner.
Just to acquire basic operational and life-saving information.
Exactly. They're the primary interface between human limitation and engineering scale.
But wait, surely modern ships are, somewhat standardized.
You would think so, right?
Yeah, I mean, if you've sailed on one standard bulk carrier, haven't you basically sailed on them all?
It's a common misconception, but the concept of true standardization at that scale is just a myth.
Really?
Yeah. Two ships built in the exact same shipyard to the exact same specs will still develop totally unique quirks.
Oh, wow. I hadn't thought about that.
And more importantly, the internal layouts, like the pipe routing or the exact cubic capacities of the tanks, they all bespoke to the owner's needs.
So a ship is essentially a highly customized, self-contained ecosystem.
Exactly. Assuming you know how a system works just because you've been on a similar vessel, that is a very fast way to sink.
That definitely sets the stakes. So since you can't just memorize a massive ship, how does the crew interact with these plans on a daily basis versus, say, in a crisis?
The text actually makes a really sharp distinction there.
Right, and looking at the daily navigation, there's a fascinating detail.
The alleyways.
Yes, some plans are treated almost like mall directories. They're displayed right out in the open in the ship's alleyways.
And the prime example of that is the General Arrangement Plan.
Unpack that for us. What exactly does the General Arrangement Plan show?
Well, according to the text, it outlines the general layout and the ship form in both profile and plan views.
So it's basically the ultimate you are here map.
Pretty much. It covers every single deck.
From the forecastle at the front.
Right. And the accommodation block where everyone lives, all the way down into the machinery space.
Down to the first and second platform decks, right?
Exactly. Those are hidden deep away, but they are clearly mapped out.
Okay, so I'm picturing this like the architectural floor plan of a giant apartment building.
That's a great way to look at it.
It tells you where the lobby is, where the boiler room is, but I have to push back a little here based on the text.
Go for it.
If the general arrangement is right there in the hallway, why does the text specifically say there are other plans kept in well-known places for emergencies?
That's the crucial difference between geography and systemic operations.
Meaning what exactly? Isn't the map of the ship enough?
Not at all. A general map is useless for a systemic disaster.
Because it just tells you where a room is.
Right. Knowing where the machinery space is geographically doesn't tell you what is actually inside its tanks.
Oh, I see.
It doesn't tell you how to save the ship if that specific space catches fire.
Which leads us perfectly to the specialized operational plans. We're moving from just knowing where things are to knowing what they hold.
And how all that incredible weight is managed.
Right, because you can't just throw cargo onto a ship willy-nilly.
Definitely not. That's where the capacity plan comes in.
And the sheer variety of volumes this plan accounts for is wild.
It really highlights how much invisible liquid goes into making the ship function.
Yeah, the text lists the cubic capacities for cargo, sure, but also freshwater, ballast water, bunkers, and lubricating oils.
It's a massive balancing act.
I was thinking of it like a 3D Tetris game, or trying to perfectly pack a moving truck.
Except in this moving truck, half your boxes are filled with water that wants to slosh around.
Oh, right, because liquids move with the ship.
Exactly, and that movement connects the immense volumes of the capacity plan to an absolute engineering nightmare.
Taking all that weight out of the water.
Yes, dry docking.
Which brings us to the docking plan. The text highlights that this plan gives the precise positioning of the docking blocks.
And the reason for that precision is terrifying when you really think about the physics.
Why does it matter so much where a few blocks go?
Well, the text specifies this prevents uneven distribution on the keel and plats.
Meaning the bottom of the ship.
Right. And it avoids what they call static local stresses.
Which makes sense. You don't want all the weight poking a hole in the hull.
But most incredibly, the text says it prevents engines' frames misalignments.
Wait, really? Let me clarify that. Are you saying if a ship is just sitting on dry blocks improperly, the stress can literally warp the engine frames?
Oh, absolutely.
That's insane. It's solid steel.
It is, but a ship is designed to be evenly supported by water buoyancy across its entire hull.
So the ocean is basically cradling it.
Exactly. When you remove that water, gravity takes over. If the blocks aren't perfectly placed according to that single docking plan, the hull bends.
And if the hull bends, the engine inside bends with it.
Yeah, and then the drive shaft won't spin correctly, and you destroy a multi-million-dollar engine before you even leave the dry dock.
Making dry docking an incredible feat of physics guided entirely by this one piece of paper.
It really is.
Well, we've established the immense physical forces of a ship operating normally, or sitting in dry dock.
But what happens when things go wrong?
Right. What happens when the very integrity of the ship is threatened?
That's when the crew runs to those well-known places to get the two most critical emergency blueprints.
Let's talk about the first one, the fire control plan.
A fire at sea is universally terrifying. You can't just call the fire department.
And you definitely can't just run outside.
No, you are trapped.
According to the text, this plan provides all the information about firefighting systems, fire alarms, and crucial escape routes.
But there is one detail in the text that is so vital here.
What's that?
It specifically mentions that the plan details the types of bulkheads.
A bulkhead being a wall.
Right. But knowing which walls can withstand fire for how long is literally the difference between life and death.
Because some walls are just steel, and heat transfers right through them.
Exactly. If you have an uninsulated bulkhead, a fire in one room will heat the steel so much that things in the next room will spontaneously combust.
Wow. So the fire control plan tells them, like, this wall will hold for an hour, but that wall will fail in 10 minutes.
You nailed it. It dictates the entire strategy for abandoning certain compartments to save the rest of the ship.
Which is a grim reality to face.
Yeah.
But there's an even worse scenario, isn't there?
Unfortunately, yes. A breach in the hull.
The ultimate worst case. And for that, we have the final document, the damage control plan.
The granular detail on this plan is astounding.
Unpack it for us. What are we looking at when we open this plan?
It clearly shows each deck and hold, but most importantly, it shows the boundaries of the watertight compartments.
So the safe zones.
Exactly. And it maps out every single opening, the means to close them, and the position of the controls to actually do so.
It makes me think of a submarine's blast doors. Just hitting a button to seal a section off.
It's very similar in concept.
But I noticed a really specific and slightly terrifying phrase in the text regarding this plan.
I know exactly the one you mean.
It says the plan includes arrangements for the correction of any list due to flooding.
Yeah, that is heavy.
Let's just pause here to really visualize this for you, the listener.
It's quite a scene to imagine.
Right. A massive vessel is starting to tilt or list because a hole on one side is taking on water.
The alarm is blaring. The deck is literally slanting under your feet.
And the crew is scrambling to find the exact engineering arrangements on this paper plan so they can deliberately counterflood the ship.
Let that sink in. To stop the ship from rolling over, you have to intentionally let the ocean into the intact, dry side of your ship.
To act as a counterweight to level it out.
Exactly. And you cannot guess the math on that. If you flood the wrong compartment, you drag the ship straight to the bottom.
So you pull out the damage control plan to tell you exactly which valves to open.
Under the most extreme stress imaginable.
It really wraps up this entire deep dive perfectly.
It does. It shows how interconnected all these documents are.
Just looking at these 5 plans, the general arrangement, capacity, docking, fire control, and damage control, they completely transform our understanding of a ship.
It's not just a vehicle you steer.
Not at all. It's this incredibly delicate balance of volumes, structural stresses, and compartmentalized safety zones.
All of which require constant, literal blueprint-level management.
So the takeaway for you listening is this. Next time you are standing on the shore and you see a massive cargo ship or tanker sliding by,
Don't just look at the metal hull.
think about the intricate paper maps and manuals hidden inside,
Some displayed right there in the alleyways like mall maps.
and others locked away for the absolute worst-case scenario. It is that paper that actually keeps the giant afloat.
It's brilliant.
But it leaves us with a final, provocative thought to ponder.
I love these. Lay it on me.
Well, we just talked about how it's impossible for a human crew to fully memorize the details of their own ship.
Right, they are completely reliant on these complex documents the moment a crisis strikes.
But as ships get larger and increasingly automated, everything is going digital.
Oh, I see where you're going with this.
Will these printed plans, with their red pen marks, remain the ultimate safety net?
Or will the ship's physical blueprints eventually become entirely digital systems?
Exactly. Systems that the crew just have to blindly trust when the power goes out. Something to think about next time you see a ship on the horizon.